Hello, this video tutorial will be looking at approximating and rounding. Now, the common misconception with the word approximating means that it is a guess. It's most certainly not a guess. It's more of an estimate of a final answer of some sort of calculation or expression. And the estimate comes from using numbers that are more user friendly, so things that are easier for us to do mental and written calculations. And the best way to do this is kick off with an example. So something like 19 times by 32,129. Now, that is not an easy calculation to do. It would take quite a while to do in your head. However, what we can do is get fairly close to the answer by approximating these two numbers, this 19 and 32,129. So if we take this first one, 19, what we're going to do is say I want to get close to a number that's close to this 19, not too far away, that's easy to deal with, a number that we like. So how about 20? That's very close, just one number away. It's not a big change, and a 20 is a nice easy number to deal with. So what about this 32,129? Well, we could say this is close to 30,000, of which it is. We could say 20 times 30,000, not too far away. However, what about 32,000? It's not that much different. It's actually much closer to the original number, this 32,129, and it's not that much harder to do calculations, because remember, we're only timesing by 20. So if we were to actually do these calculations, it would be 20 times by 32,000, which we can do in this grid method. There's a 30,000 and there's a 2,000, so we kind of split them up. So what is 20 times 30,000? Well, this is the same as 2 times by 3, which is 6, and then we've got 1, 2, 3, 4, 5 zeros, so 5 zeros, and that actually makes 600,000. Okay, so that bit's nice and easy. What about the next bit? 20 times 2,000. Well, that's 2 times 2 is 4, and then we've got 1, 2, 3, 4 zeros. So that's 40,000. So when we add this up, we get 640,000 as an answer. So that's an approximated answer to this original question. And if you're ever in a situation where you're not allowed a calculator, or you haven't got a calculator or something like that, you can say, I know roughly where it exists, around about 640,000. And often the case is that we don't need an exact answer right down to the last unit or decimal place or anything like that. We just kind of want to know roughly where it stands, and this is where approximating comes in handy. So the aim of it is to take the original numbers in the calculation here and change them for numbers that are easy to deal with but not too far away. That's the key thing. So this can be illustrated with another example. So we've got something like 8.66 times by 92.12. Now, what are we going to do? Well, take the first number. In fact, looking at the whole thing, 92.12 times 8.66 is not an easy calculation. So again, this is where approximating comes in. So take the first number, 8.66. Let's choose a number that's fairly close to it, not much of a change, easy to deal with. Okay, 8.66, right, well, hopefully the number that comes into your heads is something like 9. You could choose 8, but it's actually closer to 9. In fact, you could choose 8.5, because 8.5 is not too hard to deal with, but we'll make it even easier for today. So 9. And what about this 92.12? So we're timesing it by something that's close to 92.12, a number that's easy to deal with, not too far away from this original number. So hopefully something like 90 will come into your head. Maybe 92, depends how brave you're feeling, how good you are with your mental or written calculations. But something like this, 9 times 90, is easy to do. 9 times 9 is 81, and we have a 0, so 810. So that kind of makes hopefully some good sense. It's sensible, numbers are close, and we get a rough answer, or an approximated answer at the end. Again, as I said, you could have done 8.5 times 90. That may have been a tiny bit closer to the real answer. And again, you can just use this grid method. You've got 8 and a 0.5 or 0.5, and we're timesing it by 90. 9 times 8 is 72 with a 0, 720. 90 times by 0.5 just means half of 90, which is 45. So we get 720 add 45, which equals 765. So there we go. That's slightly different from 810, but again, it's around about the same. We're looking somewhere between, 750 and 810 or thereabouts for our answer. And again, it does depend on how close you need to be to the final answer when you're approximating as to what numbers you'll choose. But as I say, the key thing is to choose numbers that are quite close and still quite useful or easy to deal with. Okay, so what about another example, more of a kind of exam question, I suppose. So here we go. We got a question that says 11.43 times 83.95. So you go to your calculator and you type it all in. So we're not bothering with approximating at this point because you've got a calculator. You're allowed to lose a calculator, so why not? But anyway, what happens is you get an answer that comes up like this: 9595485. There's no decimal point. What are you going to do? Well, if you've got a spare calculator, then great. But if not, and we can use the use of approximating to actually find out where the decimal point should be. Now, this is where it comes in real handy, because we can say, right, 11.43, number that's close. Okay, we could say 10, we could say 12, we could say 11. So how about we just go with 11? And then we've got this 83.95. So what's close to that? Okay, well, let's just say 80. So 11 times 80 should give us around about the correct number to show where the decimal place will be. So 11 times 80, well, we can do that here. So we've got a 10 and a 1, that's 11, and then an 80. So 80 times 10 is 800, 1 times 80 is 80, so we get a total of 880 as our answer. So that's what we're saying. The answer should be around about 880 or sort of 900. So going up to the answer that was given on the calculator without the decimal point, we can just decide where that decimal point needs to go. So, I mean, if it were to go here, that's 9.59. It's no good. It's way too low. What about here? 95.95. Well, again, way too low. 959. Okay, bit high, but we're in the right ballpark. 960. But before we kind of make a decision, let's just try it on the next one. 9,595.485. Well, that's way too high. So the number that is closest and quite obviously the correct answer is 959.5485. So there we go. That's a kind of a real life use of approximating, albeit quite unlikely that your calculator will break, but you never know. So how about we look at the next kind of part of this tutorial, which is rounding. And what we're gonna do is learn how to round a couple of numbers. So let's take 1.34. Now, what we'd like to do is find out what decimal places are. So just to recap from other topics, first of all, decimal places. Here's the decimal point. The 3 is the first decimal place. The 4 is the second decimal place. If we had another number, I don't know, like 0, 2, something or whatever, the 0 would be the third, the 2 would be the fourth, and so on and so forth. So when we have to round to a certain decimal place, the idea is to say, let's say we wanted to go to 2 decimal places, rounding to 2 decimal places. We find the second decimal place, because it says 2 decimal places, which is this 4, and we're going to round it. And in order to round it, what we need to do is look to its neighbour on its right. And if its neighbour is 5 or above, we will round it up to 5. If its neighbour is below 5, i.e. 4, 3, 2, 1 or 0, then we'll leave it as 4. So in this particular case, we say 1.3 and the 4 has a neighbour of 0, so it stays as a 4. So if its neighbour, there we go, neighbour is 5 or above, then we round up. If its neighbour is 4 or below, then we're going to round down. So in this case, 0 was 4 or below, so we're rounding down, i.e. we're just keeping it the same as a 4. However, if we have another number, let's say 2.567, and we want to round this to, let's say, in this case, let's say 1 decimal place. Find the first decimal place, which is the next one to the decimal point, which is a 5. And we're going to say, right, I need to go to its neighbour, which is a 6. So this means I need to round up. 5 or above means rounding up. Okay, so what this means is that 5 will actually be added 1 onto. So we need to say 5 needs to add 1 on, which means there's going to be a 6. So that would be 2.6. So that is round to 1 decimal place. Okay, so let's look at the next type of rounding, which is to significant figures. So just keep bearing in mind what decimal places are, and let's look at some significant figures. So let's take an example, 6.5539. Significant figures, the first significant figure is always from the left hand side, so starting from the left and moving this way, the first non-zero number. And all that means is, well, at the moment is a 6. So this is the first significant figure. This is the second, third, fourth, fifth. This is very different to decimal places, because if we look at decimal places, the 5 is the first, the other 5 is the second, then third, and then fourth. So you can see that in this particular number, significant figures and decimals do actually represent different numbers. So that's quite important to realise. So let's say that we wanted to round this to first of all 2 decimal places, which we already had a little look at in the previous example. But let's do the 2 decimal places first. Right. Well, what we said is the decimal places are here in blue. So the second 5 represents the second decimal place. So in order to round that, we move to its neighbour on the right, which is a 3, and that means we're going to round it down. So that actually becomes 6.55. So that is to 2 decimal places. What about if we wanted to round this to 2 significant figures? Well, significant figures we had up here in red, didn't we? Because we said that the first significant figure, starting from the left, was the first non-zero number, which is the 6. So the second significant figure is actually this first 5 here. So this first 5 is the second significant figure. So in order to round that, we do exactly the same thing. We move to the right-hand side, or its neighbour, and say, do we round it up or down? Well, that's a 5. 5 and above always means rounding up. So the answer will be the 5 actually gets rounded up to a 6, so that'll be 6.6, and that is saying to 2 significant figures. Okay, well, what about if we wanted to round it to, say, 4 significant figures? Well, it's no different at all. 4 significant figures. The fourth significant figure is this 3 here. Remember, significant figures were in red and decimal places were in blue. So the fourth significant figure is the 3. So we know we've got 6.55, and then whatever number goes here will be the 4th significant one. It was a 3, but its neighbours are 9. We need to round it up. This becomes a 4. So this is quite easily illustrated as well in other examples. So say I have 0.004856, and this is the last example for this today. I want to round this to both 3 decimal places and 3 significant figures. So let's start with the decimal places, and we'll do this in let's say blue again, as we've done it before. Decimal places always starts from the decimal point, so first, second, third, fourth, fifth, and then sixth. Okay, so there we go, decimal places in blue. So the third decimal place, well, that's represented by 4 at the moment. 4 needs to be rounded up because its neighbour's an 8. So what we're going to do is go 0.005. There we go. 1, 2, 3 decimal places. It's been rounded correctly because its neighbour is higher than 5. So what about if we need to do 3 significant figures? So we'll do this one in red. Well, remember, significant figures, the definition is start from the left and find the first non-zero number. So this is 0, this is a 0, this is a 0. So the first one is actually a 4. It's the only number that's significant that's starting from the left. That's why we call it a significant number. So 4. So there we go. There's 1, 2, 3, 4. So we need to find the third significant figure and round that. So the third significant figure is this 5 here. Do we round it up or down? Well, look at its neighbour. Its neighbour's a 6. That means we round it up. So what we're going to do is 0.00486, and that is 3 significant figures. And remember, that blue was 3 decimal places. What we don't do, as a very quick example, and I'll do that, let's do it in green up here, is if I have, say, 1002.34 and I want to round that to, I don't know, say 3 significant figures, what I won't do is say that the 1 is the first, the 2 is the second, and the 3 is the third. That's not how it goes. The zeros need to be counted once you get past the first significant figure. So actually those 2 zeros are the second, third, and then fourth, and then fifth, and sixth, and so on and so forth. So there we go. That's approximating and rounding for today. Hopefully you've learnt something, and feel free to look on the CyberTutor library, downloadable documents and other video tutorials. So here's a single bracket expansion. Are you happy to give that a go?
Yeah. Would it be 6x plus 5?
No, actually, it's not quite that. Not quite right. Do you want to give that another go?
Oh, was it 3 times 5 as well?
Yeah, 3 times 5 as well.
So it'd be 6x plus 15.
Yeah, perfect. Well done. That's good.